All right, little math history here. So Carl Friedrich Gauss, is a very famous mathematician, physicist. Generally regarded as one of the greatest mathematicians of all time. But yeah, German mathematician. And one story that I've heard, and I don't know if I've actually fully verified this, but I learned this in math history class. I took a math history class in college. If you want to be a math major, that's one of the classes you'll take. And it's actually a pretty cool class. But anyway, but the story I heard was when he was a young boy in in school. He was a little bit of a know-it-all, right? Like he would kind of show up the teacher a lot of times and things like that. And so there's this one time where he did that exact same thing. He showed up the teacher. Kind of was a little bit of a smarty pants, and the teacher said, "All right." The teacher just wanted to kind of preoccupy him and kind of give him a consequence. And so the teacher said, "All right, count. Add up all the numbers from 1 to 100, right?" And thought that would take him a while and would occupy him for a little bit. And Gauss came back like almost immediately with the answer. And so think about how would you, if you had to add up the numbers from 1 to 100, how would you do that and get it done in just a snap, right? How would you do that? So if you think about all the numbers from 1 all the way to 100. We won't draw them all the way out, but we'll kind of show the beginning and the end. So let's see, 100, 99, 98, 97, 96. Okay, and so what Gauss figured out was that if you just add the first and the last number, you get the same thing as if you add the second number with the second to last number, right? 1 plus 100 is the same as 2 plus 99 is the same as 3 plus 98, right? Is the same as 4 plus 97, right? So you're just going to get a bunch of these sums of the first number and the last number, right? And then Gauss figured out, well, how many of those are we going to get, right? So we have this 101, this sum of 101 that we're going to keep getting by pairing up the first and the last number. And how many pairs are we going to have? Well, if there's 100 numbers overall, that would be 50 pairs, right? 100 divided by 2 is 50. So Gauss figured out that if we just multiply 50 by 101, we would get the sum of all the numbers from 1 to 100, okay? And so 50 times 101 is 5,050, right? And so that's the sum of all the numbers from 1 to 100. And this works with any numbers, any sequence of numbers. This works as long as the sequence has a regular progression in terms of like you're adding the same number or you're increasing by the same amount every time. This formula will work. And so this formula, along with these other formulas that are here, right? So this is the one that Gauss figured out right off the bat. Like this is saying, okay, if you add the first number, right, which in this case is 1, with the last number, right, so that's n plus 1, and you multiply that by n over 2 by how many pairs you have, right, because this is the total number divided by 2 gives you how many pairs. This will give you the sum of that set. Okay, so this works, like I said, with any set of numbers. So if I go from 1 to 1,000, right? Oops, sorry, put the 1,000 in the wrong place. They're 1 to 1,000 of I, right? And this has to be I here, so we're just adding up 1 plus 2 plus 3 plus 4 all the way up to 1,000. So that would be 1,000 plus 1, so it'd be 1,001, right? That's the n plus 1 part. And then I would multiply that by 1,000 over 2, right? So 1,000 over 2 is 500. And so I'd just multiply that together, and I would get 500, right? So it'd be 500,500. All right. So that works with any any sequence of numbers. Okay. So then here's another one. If we adding up all the numbers, if you add up the squares of a bunch of numbers, like 1 squared plus 2 squared plus 3 squared all the way up to n squared, then we have a formula for that. And that's similar. We have the n times n plus 1, but then we have the 2n plus 1 over 6. And that might be something that I ask you to prove as kind of a bonus question or something at some point. But yeah, it's kind of a fun proof. And then we have the sum of a cube. If we sum a bunch of cubes from 1 to n, 1 cube plus 2 cube plus 3 cube plus 4 cube, etc., then we have this formula here. Okay. All right, so those are some formulas that'll come in handy, and just a way to, excuse me, instead of writing out all these numbers and evaluate them, we have these shortcuts, right? And so that's what these are. These formulas provide us shortcuts. So if you're just going from like 1 to 5, that might be easier just to do 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube, right? But if you're going from 1 to even 10 or 1 to 20 or 1 to 100, then this is going to be a lot faster, right? Any of these are going to be a lot faster.